I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing free body diagrams for an object on an inclined plane. So here we have a situation of a box sitting on an inclined plane. We're going to say that in this case there is no friction, that it's on a frictionless plane. And we can see that the object is going to be sliding down the ramp. So we're going to start like we do with every free body diagram with the system schema. And we know that the ramp is sitting on the floor. Now when we draw our interactions, we know that the box is interacting with the inclined plane, the ramp, and the earth. We know that the earth is interacting with all objects, the floor and the ramp. And we know that the ramp and the floor are interacting as well. So we're drawing our free body diagram for the box. So we'll draw our dash shape around the box. And we can see that we only have two interactions acting with the box. We have the normal force from the ramp, and we also have the gravitational force from the earth. Now, here's the tricky part to drawing free body diagrams for an inclined plane. We draw the x-axis, the horizontal axis, always is drawn parallel to the surface. So we draw our axis parallel to the surface, it's going to look like this. And remember, we draw dashed lines to represent the surface, so that way it doesn't interact or look like it's a vector. So I'm going to draw it parallel, and then I'm going to move it, which you can't do on your paper, so you're just going to have to line it up so that it is close to parallel. And I'm going to label it my x-axis. It's really important to label x and y, especially when you're drawing for inclined planes. The y-axis is always drawn perpendicular to the x-axis, so we've got to make that a right angle. This is a big mistake a lot of times, is that we forget to draw them at a right angle to each other. That's the first thing you have to do. So then we shrink the box to a single point, and then we're going to draw our two vectors. We know that the normal force is defined as the perpendicular force between the surface and the object. And perpendicular to the surface and the object means that it's always going to be on the y-axis, because the y-axis is always perpendicular to the x-axis, which is the surface. So we draw and label the normal force. And because this is on Earth, it's not in space or anywhere, I'm going to draw the gravitational force pointing directly down on my paper to the bottom of my page. So my gravitational force points straight down. Now, again, if this is the free body diagram, if you're taking an AP class, this is the free body diagram, that's your answer. You're not going to add anything else to that free body diagram. If you are going to add things to it, you need to draw a working free body diagram. So I need to figure out where this angle theta goes. So theta is, if we remember the rule, we'll prove it here, but if you just remember the rule, you'll always put theta in the same place for inclined ramp problems. So we can see that the horizontal line, that's the bottom of the ramp, is the same line that we have here, and that x and y axis. So we have that angle theta that is made with the angle and the inclined ramp in the box. And we know that the x and y axis make a 90-degree angle. So that means this angle down below is going to be 90 minus theta. Then we can see we have the gravitational force vector. And if the gravitational force vector makes a 90-degree angle with the bottom of the ramp, the horizontal part of the bottom of the ramp, then that means this angle here is going to be the angle theta between the force of gravity and the y-axis. So we know that the angle is always going to be between the y-axis and the force of gravity for problems involving an inclined ramp. So we could draw our working free body diagram. And we know that our angle theta is going to be between the gravitational force and the y-axis. Now we're going to draw our vector components for gravity. So remember, the vector components are the ones that are always perpendicular, because the actual force vector is the hypotenuse. So that means the red vectors that I'm drawing have to be perpendicular to each other, because FG is going to be the hypotenuse, which makes the component that's pointing down and to the right FG sine theta, and the one that's opposing the normal force is FG cosine theta. So now we have our working free body diagram, and we can go to our Newton's laws equations to make some solutions. So here is how you draw free body diagrams for an object on an inclined plane. I hope you have a great day and an even better tomorrow. If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.